Two large charged plane sheet of charge densities sigma and minus sigma centimeter square are arranged vertically with a separation of d. We'll see the diagram here. See, this is the diagram. Okay, these are two sheets and it is separated with the separation of the d here. Now we need to find the expression for electric field at points. First one, to the left of the first sheet, second, to the right of the second sheet, and between the two sheets. So we'll see the first case here, that is electric field in the region left of the first sheet. Left of the first sheet, that is given by E1 is equal to E1 plus E2. Then E1 is equal to, that is sigma divided by epsilon naught minus sigma divided by 2 epsilon naught. And E1 is equal to plus sigma divided by 2 epsilon naught. This is the equation. It is towards right. And second case, electric field in the region to the right of second sheet. Then E2 is equal to sigma divided by 2 epsilon naught minus sigma divided by epsilon naught. Then E2 is equal to minus sigma divided by 2 epsilon naught. It is towards left. The third case, that is electric field between the two sheets. Then E3 is equal to E1 plus E2, that is sigma divided by epsilon naught plus sigma divided by 2 epsilon naught, which gives the resultant 3 sigma divided by 2 epsilon naught. This is the equation. This is electric field towards the right. A spherical conducting shell of inner radius R1 and outer radius R2 has a charge Q. A charge, we need to find here, a charge Q is placed at the center of the shell. Find out the surface charge density on the inner and outer surface of the shell. B part, is the electric field inside a cavity with no charge 0, independent of the fact whether the shell is spherical or not. Explain. Okay. So we'll see the diagram here. So this is the diagram. This is a spherical shell. The inner radius is R1. This inner radius is R1 and the outer radius is R2. And the charge is Q. Okay. Then the surface charge density on inner surface of the shell is that is sigma 1. We can write this one as sigma 1 is equal to minus Q divided by 4 pi R1 square. Okay, where the surface charge density on outer shell is given by, that is sigma 2 is equal to Q plus Q divided by 4 pi R2 square. Okay. Then the part B question here. Is the electric field inside a cavity with no charge 0, independent of the fact whether the shell is spherical or not. Okay. Consider the Gaussian surface inside the shell. The net flux is 0 since charge net total net is equal to 0. According to Gauss law, it is independent of shape and size of the shell.